Hello, my name is Jon Stueve. I'm manager of Automation Anywhere training, and this is controlling bots in A2019 using loops, conditions, and data types. I want to remind you that bots are controlled by logic, and that's not necessarily calling Spock-type logic, but bots follow a defined set of steps to mimic a process that a human performs. And initially, that's started by doing a recording of the steps that a human's producing. And then after we do that recording, we usually add additional commands and actions to the bot to give it a logical structure. So that logic also allows the bot to be more resilient, respond to information that's developed at runtime, and be able to see what's happening on the screen and respond to it by understanding what's happening within the environment that the bot's running in. So there's three different building blocks that we can use for logic that's in addition to the objects that it would be using during the execution of the bot. The first bot is variables, and specifically in A2019 typed variables. Variables in A2019 are strongly typed, which helps us maintain the integrity of the data. Numbers are numbers, strings are strings, date times are date times, and we have to remember to explicitly convert data between different data types as we're using the data in different elements. Another building block are conditions, or if-then expressions. Conditions contain actions that are only executed. It's a block of code that's only executed if the condition is true. And we can also branch the flow of the bot by using an if-then condition that contains an else. And if one thing is true, we'll do one set of actions. And if a different set of actions is true, we'll follow a different path. So conditions allow us to branch how the bot flows. Loops are actions that contain the steps we're going to do for every iteration of a pattern. And that could be a tabular set of data, and we want to work through each row. We could loop through each email that we receive from an email server, or we can loop through a certain number of times. We can also loop while a certain condition exists. So we can check the condition using something like a condition variable or an if-then. And if that condition exists and is true, we'll continue through our looping and continue doing the steps within that loop block. To start off, let's talk more about variables. Variables are containers that hold values. Specifically, variables have a name. That's how we're going to reference them. That's how we're going to choose them. And usually the names we have some sort of convention into how we name them, so we can understand the data type of the variable by looking at its name. Variables also have a value. For a number, that could be just a string of numerical characters and a decimal point. For strings, it could be any typable type of character. For a date time, it's a specific type of format that describes a date and a time. And other elements can be included in the different types of variables that we have. And also each variable has a type. And the type is very specific as to what the data is stored inside that variable. It's important, one of the differences in A2019 is that our variables are strongly typed. And we need to keep that in mind as we're building our bots. The benefits of having strongly typed variables is now we can create some certain actions that we can do with those variables. So for a string variable, we have a large list of actions within the string package that does manipulation of the data within the string. We can extract specific text from the screen. We can assign a new value to a string that might include concatenating multiple string variables. We can convert uppercase or lowercase. We can find and replace things. We can extract a certain substring from that string. Usually we prefix the name of the variable with a lowercase s to define it as a string type variable. Similarly, numbers are for doing things with data that is numerical. So characters that have number characters 0 through 9, as many as we want, including a decimal point to make floating point numbers, those are available to us. With that, we can use the assign package or the assign action in the number package to give that variable a value. And the assign action allows us to also do mathematical operations, multiplication, division, subtraction, and division. We can also use this to increment and decrement. So if you're using a numerical variable to count how many times you're doing something in a loop, you can use the increment and decrement variables to assign that. There's also a random package. In the number package, there's a random action that allows us to retrieve a number of a random value. And that's helpful if we're going to do some sorts of simulations. There's a new variable type in A2019 called Boolean, which stores either a true value or a false value. It can either have the state of true or false. These types of variables are often called flags. So the icon we're using here is flags, and it just tells us if something is true or not. So when we name a Boolean variable, we want to kind of give it a is type of action in it. So user is registered can either be true or false, and we can store whether they're registered or not in a Boolean variable as either true or false. And we have actions that we can do with Boolean variables within the Boolean package. A file variable is going to reference a specific file either in the control room or the desktop file system. And we can use that file in various actions within the bot to do parts of those things. We can also use that file to download a CR file, and we can use that file action to download something from the control room into the active bot runner device, execute some things on that file, and then remove it by using delete within the file package. So lots of different things we can do with a file type variable. A list is something that we had in previous versions, but in A2019, we've added a lot more capabilities with it. The list subtypes include all the A2019 types, including other lists, and we can include a list of strings, a list of numbers, a list of Booleans, etc. With all of these lists, we have a package to do more things with list type variables, which including adding items to the list, removing items from the list, getting the value of a specific item, setting a certain item, determining the size of the list. All these types of actions are available using the list package. We usually preface list type variables with the lowercase l. A dictionary variable is for storing key value pairs. So each element within a dictionary has a label or a key, and then a value that's associated with that key. So one example might be the username and password that might be used in a website that you're logging into. You can have a dictionary variable that stores a username key and a password key, and we can populate those values with the appropriate information. The dictionary subtypes, so you can have a dictionary of strings where all the different keys are string values, a dictionary of subtype number where all the different values associated with keys are numerical, or Boolean, which is either true or false. There's also a subtype of any, which could be any of the keys could be any of those types of variables, and would have to do a type conversion into the strong type after we retrieve the value from the dictionary. The dictionary package has all the actions that we can do to manipulate dictionary type variables, and dictionaries are often used as a holder for our information of the same that has to do with the same thing in an object. For example, if we're looping through emails, inside the loop, there's a dictionary variable that gets assigned all the information that's associated with an email, such as email to, email from, who was copied on the email, what the subject of the email is, what the body of the email, when the email was received. All that information is stored in a dictionary type variable under those specific keys. We usually start the dictionary variable by prefacing it with a D, and then the information of what that dictionary variable is going to hold. A record variable is used to store a single row of data, usually from a table. So if we're looping through a table of information, either from a database or a spreadsheet or a table on the internet, each row of that, as we're looping through that table, we'll get access to each row by storing that line of data into a record variable. Record variables should be prefaced with the lowercase r, and we can reference the different columns stored in that record either by index or by name if the tabular data includes a header. And talking about tabular data, we have a table data type or data table, and we have a data table package that can do additional actions to that variable in memory. It's created to read data from different sources, either a the results of a SQL query or the contents of a CSV file, which contains rows and columns. An Excel file or a range of cells within an Excel file could be stored within a table. And we can even write that table in memory to a file or to a specific place within a spreadsheet using different commands and actions within our different packages. Table variables are usually prefaced with a lowercase t. Window variables are for storing window titles, and we can adapt those window variables to include wildcards to help with windows that change their titles often. Usually they're captured automatically when you do a capture action from a capture command or through a recording. The window variable is automatically created by the system. And they usually start with window-1, window-2, but you can always rename those windows for a more meaningful name. When you do, make sure that you do preface that window variable with a lowercase w. Form variables are new in A2019, and they include a reference to a specific form that we're using as part of an attended bot or a human-bot collaboration use case. It helps us to be able to display information to the user and also use the information that the user inputs into that form for bots downstream. If we're using form variables, you should prefix the variable name with an F. The datetime variables are storing a single date time, a specific date and time. So usually that's most associated with something called now, or what is the date time now. We can use this in conditional statements, file operations, data mapping to determine if it's before or after. We also have a datetime package that includes actions we can use with the datetime variable, which includes converting it into a string in a specific format that can be defined either using common formats, ISO values, or we can use a customized pattern. Documentation on this is well defined in our documentation portal. The final type of variable is the any type of variable, and it can store a Boolean number or string data type, and then we can use that any variable and convert it and store it in a normal type of typed data structure. It's helpful when we're uncertain of the output of a particular action. And often, as we're getting information from subtasks through a dictionary variable, we might want to include any as a dictionary variable because that subtask could be including different variables of different types, and we want to be able to capture all those different variables into one dictionary. So the any type is very helpful in that use case. For any variables that you do use, preface that variable with a lowercase a. Next thing I'd like to talk about is conditionals. Most often when you talk about conditionals, you're thinking about an if statement. And we have an if statement action, a if-else or an else-if action that we can extend that condition into another branch. There's an else condition that works if the first condition or several conditions aren't met. And then, of course, we have an end if to end the block of code that we'll be doing for the conditional statement. It's listed as a block of code, so it's shown within a singular block within the flow view, or it's indented a certain way in the list view. There's lots of different conditions that you can use, so we can check to see if an application is running or not running. We can check the value of a Boolean to see if it's true or false. We can check to see if a dictionary contains a specific key. We can check to see if a file exists, doesn't exist, what the file date is, what the file size is, if it's greater than or less than. We can check to see if a folder exists or doesn't exist. Very important as we're checking the environment of our bot agent to see if it contains the folder that we want to store data in. We also have things we can do with image recognition. Using the image recognition technology, we can check to see if an image is found within an image file, or if a window is found within an image file. All sorts of things we could do with image recognition, and checking to see if that image is present is helpful as we're doing automations. We could check to see if a JavaScript that was executed was successful or unsuccessful. For some of the previous legacy app automations that were imported or migrated into A2019, we have some specific types of actions we can check for those. If a Windows control is active, or not, or if it exists or does not exist. We can use those here. The list action, if a list contains a specific variable, we can check that using the if condition. If a number variable is greater than, less than, equal to, that condition can be used using the conditional statements. We can check to see if a network resource is available to see if it responds to a ping using an if condition. We can check to see if an object exists on a page using a recorder object condition. So we can check to see if a button exists on a page or an application window. We can check to see if there's a certain text field that's available through that object. So anything you can capture with the recorder, we can check to see if it exists using the recorder object if condition. We can check to see if string variable values are equal or not equal to static text or another string variable. We can check to see if it contains or doesn't contain, so it could be a part of a substring using an if condition. If we're trying to run a task bot from a task, we can check to see if that execution was considered successful or unsuccessful, or if a VB script was successful or unsuccessful. And finally, we can check to see if a window exists or does not exist, checking the windows variable. The next section I would like to talk about is loops. So loops are used to take actions within bots until a condition has been satisfied. Sometimes that's different types of iterations, which are iterating through a loop. So we're going to continue to do this until we run out of rows in a table. That's probably the most common loop that we use in bot building. Additionally, the loop package contains actions for continue that allows us to stop execution of the current iteration and go back to the beginning of a loop and start over with the next data item. So if we got to a certain point and we want to just go back and start with the next row, we can use the continue action. The break action as part of the loop package immediately stops the execution of the loop at that point and exits the loop and continues execution after the loop block. And so it's one way to stop the loop from continuing at a certain time and go back to normal execution of a bot. There's different types of iterators when we're talking about a loop. And so the iterator for each row in a CSV or a text file, iterator through each row in a data table, an iterator through each row in a database query. We can go and loop through each key value in a dictionary, or we can loop and get the value for each key in the dictionary. Either of those can be worked through a loop. We can get the value of each email, and that email is going to return a dictionary variable that contains all the information for that email, the from address, to address, CC, etc. Excel Advanced requires Excel, so this is the type of actions we're going to work with an Excel spreadsheet that has the spreadsheet open. And we can check for specific rows. We can loop through specific rows, all the rows, or define a cell range. We can also do the same for Excel basic type files, and these are XLSX files. And Excel is not required to do these, but we can loop through the same sort of features. All the rows in an Excel basic spreadsheet, specific rows, or a range of cells within that spreadsheet. We can also loop through each file in a folder path. So if we give a folder path, it'll loop through each file, and a dictionary variable will be available, is returned that contains the name and extension of each file in that folder. If we can also loop through each folder within a folder. So if we have a directory structure on the hard drive that has folders within folders, we can use the folder, looping through each folder within folder to loop through all those folders. And it's often used also with the loop through each file in a folder as well. We can loop through each item in a list. We can loop through each loop. So we can loop through as a count for each element. So we can loop 10 times, 9 times. We can use a number variable to define how many times we'll loop. Another neat thing is to loop through each value in a record. So as we loop through each column through a table, if we loop through each row in a table, we can also loop through each column using the loop through each value in a record. Makes for some interesting, very tight and concise looping constructs. We do have access to the Office 365 calendar, so we can actually loop through each meeting in that calendar. And we can loop through each row in an Excel 365 web-based spreadsheet. And that requires some access through through Microsoft APIs. And we can also loop through each node in the XML dataset and return a value for that node. We can also loop while a condition exists. So if we go through this and you seem like you're repeating, this time we're looping if a condition is true or false. So it's like combining a loop and an if condition into one command. We're going to loop as long as an application is still running or as long as an application is not running. We can loop through as long as a Boolean condition exists or doesn't exist, or as long as the dictionary contains a specific key. So each time we loop, we're going to check that key, we're going to check the Boolean condition, we're going to check the file information, or anything within image recognition. Anything that we have a condition for, we can use that as a condition for our loops, including JavaScript, any legacy application for bots that have been migrated from previous versions, list values, numeric values. We can continue to loop as long as we have access to a specific network resource that is pingable. We can loop through an object as long as that object remains existing. So if we have a table and that table has a next button, we continue to loop through each of those different tables every time the next button is pressed until the next button stops. Finally, we can loop through the string values that are available, whether or not a task bot was successful or unsuccessful, loop while a VB script is successful or unsuccessful, or loop while a window exists or does not exist. Loops, if conditions, steps, all of these are different types of blocks of code that are shown in the list view as a indentation or in the flow view as a block. So you want to be very careful while you're working with steps and loops and if conditions that you're working with things that are within blocks. And those are usually defined by a difference in color that could be a little bit, you want to be careful with where you're working there. It's also helpful when you're working with loops and conditions or blocks of code to include comments to tell you what this code is going to work. So the comment action and the comment package allows us to add some additional information to these blocks of codes. You can also use the comment to comment where you left off. If you have an automation you've been working on and you know tomorrow you're going to do some additional things, you can add a to-do in the comment section so you can give yourself an indicator that you need to do some additional work inside this step or this block, and you can read the comments to see how they work. And comments usually show up as bright green as the color of the node, is also green as the line of code in the list view. And that concludes the presentation on controlling bots through loops, conditions, and data types. I like to call those the lions and tigers and bears of building bots. It's very important to pay attention to your loops, conditions, and data types as you're building bots. And with this information, I hope you're able to go be great.